let's look at a small example of a loop, something related to our quiz score example. So remember at the beginning of this lecture series, we talked about how we could write a program that stores 5 quiz score values and calculates the average. And we said we could print those all out as individual instructions without using a loop. But we said it would be smarter to use a loop because it would make our program more scalable. We'd be able to increase the number of quiz scores that we process without exhausting ourselves typing in all the individual lines of code. Let me do a page break here so we can see this all on one page. Okay, so this is what our algorithm would look like. We want to repeatedly ask the user to enter a quiz score and add that quiz score to a total value. And so those are going to be the 2 steps that we want to repeat in our program. We want to repeat asking the user to enter a quiz score and then adding that quiz score to a sum that's going to accumulate the total of all the different quiz scores. Now we have some extra steps in here. First, there's a lot of comments just so that you're able to parse through this on your own later on. If you return to your notes later for review or something, you're like, what does all of this mean? And there's lots of comments in here to help you track that. And you can see that there's some initialization steps up here. Think to yourself, which of these do you think is the loop initialization? Consider the fact that this is our loop test, so we're using a variable called count. Which of these 2 statements do you think would be the initialization step for our loop? If you guessed the second one, count equals 0, you are absolutely correct. That's the initialization step for the loop counter. You can tell because it has the same variable that's used inside the loop condition. We have this other initialization step up here where we set the sum of scores equal to 0. That's just a regular initialization, just an algorithmic step in our program. It's not really related to the loop control itself, though. So we have both of those variables set up. As we're executing through the program, let me go ahead and do that. Let me kind of trace through. I'm going to open another Word document to let us trace through this program. And tracing through a program is just a fancy way of saying, kind of pretending to be the computer and seeing what's going to happen. It's a really critical step for being a successful programmer and working with software. You have to be able to slow yourself down and execute instructions that would be in Python or on a problem on a piece of paper, and slow yourself down so that you execute them in exactly the same way that the computer would. This is really important because it helps you when you're debugging a program. If your program's not working right and you don't know how to trace through it, it's going to be really, really frustrating because it's just kind of like staring in a black box then. If you don't understand how the individual instructions work, then you're not going to be able to kind of slow yourself down, take it step by step, and then see where your algorithmic process doesn't match what you intended it to in code, and you won't be able to locate problems. It's also really important because we use it a lot on quizzes and tests where maybe we'll give you some example code and ask you to trace through it and tell us what's the output going to be whenever you complete this code. And so it's important to develop skills for that reason too. All right, so in this program, the first step, the first thing the computer would execute would be this line that says sum of scores equals 0. So I'm going to set up a variable sum of scores. And right now that has a value 0. I'm just going to denote any value that a particular variable has just sitting next to it. So what's that saying is the computer is going to go to memory. It's going to make this space that's big enough to hold a whole number value. It's going to associate this identifier, sum of scores, with it. And then it's going to assign that box in memory the value 0. That's step number 1. In this program, the next step is the initialization step for the loop. So we're going to set up this additional variable count. And again, the computer's going to go to memory. It's going to create a memory space that's big enough to store a whole value. It's going to associate this identifier count with that memory space. And then we're asking it to assign the value 0 to that variable. We're going to do that. Then the next thing that happens in our program is we encounter the while loop. When the while loop is encountered, we always evaluate the expression that's in the parentheses. So we want to ask ourselves, is the current value of count less than 5? So checking out our current value of count that's over here. It's 0. So we're asking ourselves, is 0 less than 5? And we're going to get a true response there. And because the response is true, that means we have to execute all of these indented steps, everything that's part of the loop body. The first step that's inside the loop body is going to prompt the user to enter a quiz score. So it's going to print out to the screen, enter a quiz score, and then it's going to treat whatever input they give us as floating point data. So it's going to store it as a decimal, and it's going to assign it to a variable called quiz score. So I need a new variable here from keeping track of my memory. And let's do a little like input output window up here so that we can keep track of what we entered in this example. And then I'm going to call this one my memory worksheet. That's like keeping track of what's going on inside the computer's memory. Again, the input and output, that's like what's being displayed and entered on the screen. So the computer's going to type out for the user, enter a quiz score. That'll be output. And then the user is going to enter some value. Let's say they enter a 10.0. So it's going to read in their 10.0 and store it in our variable called quiz score, because that's where we're assigning the input value. Cool, cool, cool. And then the next step in our loop body is to update the value of sum of scores. So we're going to evaluate this expression on the right-hand side of the assignment operator. We need to get what's the current value of sum of scores. Currently, sum of scores is storing the value 0. And then we want to add to that the current value of quiz score. So that's 10. So we're adding together 0 plus 10.0, and we're going to get the answer 10.0. And then we're going to store that, we're going to assign that result back to the variable called sum of scores. So we're updating the value of that variable. And you can denote that however you want on your memory worksheet. Sometimes I'll do a strike through so that I can keep track of like all the different values that a variable is taken on over the course of a program. You can do that if you want to. Sometimes it's fine if you also just replace the current value with a new value. And we'll do an example when we come together in class so that I can show you kind of like live on a whiteboard what that looks like, tracing through stuff on paper. All right, cool. So we have updated the sum of scores value. Now we're ready to move on to the next indented step. The next indented step says I need to update the value of count. So on the right-hand side of the assignment operator, I'm going to evaluate this expression, count plus 1. So I need to get the current value of count, which is 0. Then I'm going to add the value 1 to it, so 0 plus 1, and then I'm going to store it back in my variable called count. So we're going to update this value, count. It's not going to be 0 anymore. Now it's going to be 1. And remember, we're using that counter to keep track of how many times has the loop body executed. And because we've just gone through this algorithm that's the loop body one time, we're now reflecting that in the value of count. We've updated it so that we have reflect the fact that we have executed the loop body one time. That's our last step in the loop itself. So now we've reached the end of the loop. We know because the lines below it aren't indented, so Python will know that those are not part of the loop body. We always have to go back up to the top to the while statement and reevaluate the loop expression, this expression inside the parentheses. So we want to ask ourselves, is the current value of count less than 5? So right now the current value of count is 1, and 1 is less than 5. So we're going to get a true result here. That means we're going to execute all these statements in the loop body again. And so we need to start out. The first step says, print to the screen, enter a quiz score so that we prompt the user for input and store whatever they enter as the variable quiz score. We're going to print out again, enter a quiz score. And then say they put in the value 9. Excellent. So whatever they enter here as their data, we're going to capture that information and update the variable quiz score using that data. So now quiz score is not going to be 10.0 anymore. It's going to be 9.0. Oops. And we're going to execute the next step in the loop body that says I need to evaluate this expression that's on the right-hand side of the assignment operator. I need to pull out the current value of sum of scores, that's 10.0. Then I want to add to it the current value of quiz score, that's 9.0. So 10.0 plus 9.0 is 19.0. And then we're going to assign that to the variable called quiz scores, because that's what's on the left-hand side of the assignment operator. So up here, we're going to make a new value, 19.0. Sum of scores is no longer going to be 10. Now it's going to have this new value, 19.0. And then our last step of the loop says we want to update the value of count. We need to find the current value of count and add 1 to it. Current value of count is 1. When we add 1 to 1, that's 2. So we're replacing the old value with the new updated value 2. And that's the last step of our loop body. What happens when we get to the end of the loop body? We go up to the top and we have to evaluate the loop condition again. So we're going to ask ourselves, is the current value of count, which is 2, less than 5? And that, of course, is true. And right about now is where people start to feel like this is not super interesting. My brain wants to move on and do something more interesting. But you have to hang with it and suspend your boredom. Pretend like you're the computer. Computer doesn't care about being bored. It's happy to repeatedly apply the same algorithm over and over again. And so you have to stick with it. And I promise that if you're able to stick with it, it's going to make you a much, much more effective programmer. You're going to have more understanding for the algorithms that you write. You'll be able to track down errors in your program, and you'll be more successful on exams and quizzes and homework problems as well. All right, so we're up here and we know that count 2 is less than 5. So we're going to do this whole process over again. And we know there's 3 steps. The first one is print out the input prompt, enter a quiz score, and let the user enter a new value. We'll say they enter an 8.0. And then whatever they enter over here is going to be stored as quiz score. So we're getting a new value in our quiz score variable. And then the next step is to calculate this arithmetic expression. We want to get the current value of sum of scores, which is 19, and add to it the value of quiz score, which is 8. And 19 plus 8 is 27. We're going to store that back in sum of scores. Sum of scores will become 27.0, replacing that previous value. And then our final step in the loop is updating the value of count. Anytime you see count equals count plus 1, it means just add 1 to the current value of count as your update. So we'll be storing at 3. Then we have to go up and evaluate the loop condition again. We want to check to see, is 3 less than 5? And that's true again. So we're going to repeat all the steps in the loop body. We're going to ask the user to enter a quiz score. Say they enter 7. We're going to store that value 7 in our variable quiz score. Then we're going to perform the arithmetic operation. We're going to add the sum of scores and quiz scores. So we're adding 27 plus 7, that's 34. And then finally, we want to update the value of count so that we add 1 to it. So it's 4. Excellent. Then what do we do after we've done the update step? We have to go back up and evaluate the loop condition again. So we're checking to see, is the current value of count, the current value of count is 4. Checking to see if that's less than 5. And it is, so we're going to do all these loop body statements again. Enter a quiz score. Say they enter 6.0. Whatever they enter as the input, we're going to store it in this variable quiz score. Got 6.0 here. That's replacing the previous value. Then we're going to update the value of sum of scores by adding the current value of sum of scores, which is 34, and adding quiz score to it. So that's 34 plus 6 is 40. And we'll store that back in our variable sum of scores. And then finally, we're going to update our value of count. When we add 1 to 4, we're going to get 5. That'll be our new value that gets stored in the variable count. And now it's an exciting moment. What do we do when we get to the end of the algorithm? For the loop body, we have to go up and evaluate the loop condition again. We're going to check to see, is the current value of count, which is 5, less than 5? And everybody's like, thank goodness. No, it is not. That is false. 5 is not less than 5. And when you get that false statement for the loop condition, that's when you don't have to execute the loop body anymore. The computer's going to start with the unindented statements that are right under the loop. So all the statements that aren't part of the loop body, it's going to execute those. And we have 2 in this program. The first one is an arithmetic expression. We want to find the average score by calculating the sum of scores divided by the count. So sum of scores is 40.0, and we're going to divide that by 5, which is the value of count. And we're going to store that result as average score. So 40 divided by 5, that's 8.0. And then finally, the last statement in the program is a display statement. It's going to print to the screen the label, the average quiz score is, and then it's going to print the contents of our variable called average score. It will print out the 8.0. So we successfully wrote a program that uses a count-controlled loop to repeatedly ask the user to enter a score and then find the average of all the scores that they entered. And notice that this program, unlike the one we looked at the beginning of class, scales really, really well. What I mean by scales is, suppose we wanted to change this so that instead of 5 quiz scores, we had 500 quiz scores. Well, guess what? All we'd have to do is come in here and change the number of loop iterations. If we change the number of loop iterations to be 500 instead of 5, now the same amount of code executes 500 times instead of just 5 times. Or we could make it so that it was 5 million times. I don't know if I got enough zeros in there. I think so. And again, all we had to do is change that one line of code. That one line of code is what controls or counts how many times this loop body will execute.